In this video, we're going to show you how to do matrix algebra in R. And to do it, we're going to motivate it with an example of the following object, which we saw previously. So to do this, I'm going to generate some data. I'm going to use a formula that Mr. Morales in high school taught me in my physics class. And we use the very well-known formula. What I'm going to do is I'm going to define the distance that an object has fallen using this formula that includes the acceleration constant, 9.8 meters per second squared. I'm going to take 25 observations at times between 0 and 3.4, and I am going to form now the path, the distance that the object has fallen at each one of those seconds using that formula. I'm dropping it from the Tower of Pisa, so that's the height in meters, approximate height, and then the formula says it's the initial velocity, which in this case is 0. We don't have to write that, but I'll write it anyways, minus negative 0.8 g, 1/2 times g times t squared. So that's our formula, and now we're going to create the data, which includes an error term because there's observational error. So I type f plus r norm. Here's my observational error, and with an SD of, we'll say 1. And we can see how that looks. XY, let's put some labels on it real quick. Time in seconds, and Y lab is, what is it? Distance in meters. So let's see, oops, not meters, meters. Okay, so let's see how that looks. Oh, not t, but not x, but t. Time. All right, now there it is. And we can also see the actual path. That's the data that we observed, but the actual path is this. Nope, f. Y has the error, so we have this. Okay, good. So now imagine you're Galileo and you do not know this formula. So you want to estimate it. You can see it's a parabola. So you go back to your data just like that, looks like that. We want to estimate the 3 parameters that define a parabola. Right? In this case, they should be 56.67, 0, and negative 0.5. But we don't know it, so we want to find out what it is. Okay, so that's our task, and we want to figure out how to do that. Now, what we've talked about our least squares errors is the standard way that we do this in data analysis. So we're going to define the residual sum of squares, a function that gives us back the residual sum of squares, so that we can motivate the use of linear algebra. We're going to do that in the next video, but now I'm just motivating this. So let's start by just creating this function. So I want RSS, and I want to define it for 3 variables. What else do I want? So now I want to create the residuals, which are y minus beta 0, I should put a parenthesis here, plus beta 1 times t plus beta 2 times t squared. And by the way, the reason I don't use t is because that is a function in R. It's a transpose function, so I use tt. You could use something else, but that's why. All right, so then what is the sum of squares? It's sum of the squares of the residuals. So let's see if that worked. Let's try out a few values now. So what I'm going to do now is I can now search through all 3-dimensional numbers which one minimizes this. That's an impossible task. We're going to use math to do that, and that's one of the motivations for learning linear algebra, is that it provides us a very nice way of arriving at this solution. So just to give you a sense of what's going on here, let's just create a vector real quick, just to see how this works. Let's see. I'm gonna keep 2 of them fixed, and I'm gonna just move one of the parameters, because otherwise we have to make 2-dimensional or some sort of 3-dimensional plot. So let's see what we have here. So let's try a few betas, 100 of them. No, let's not go to 10. We know that can't be right. Okay, so let's go to 0, and then let's try a few values. All right, so how does this work? So I'm going to get some RSS values, and I'm going to use the function sapply, because I'm going to apply RSS, the RSS function, to each of the entries in beta. So it goes RSS, and now I'm going to fix two other parameters. Beta 0, I'm going to just say 55, and beta 1, I'm just guessing, is some Galileo, and I'm guessing, and beta 1 is 0. Okay, so how does that look? I can plot that as a function of the betas, and it gives us an idea of where this minimum is. I'm going to make it a line. Let's see if this works. No, what did I do wrong? I missed the 2. There. No, now what did I do wrong? Oh, did I not define it? Okay. Oh my, sorry. Here it is. All right. There it is. So you can see there's a minimum there. Of course, that's just, we fixed 2. We don't know those other 2 are right, but if they were, we could see the minimums here. Now we can try another set of values. Let's try, let's change this to 65, and then let's put a line so we can see the line there too, and see what that looks like. Let's see that. Let's see how that looks. Let's do another color. I already have this, so I don't need it. And there's the other one. Okay, so now we can see that this minimum is better than that minimum. But again, we would have to be searching through a bunch of different values in 3 dimensions. And that's not really the approach we want to follow. We're going to use linear algebra. Now, before we go into that, I just want to point out that if you are using R and you want to do something simple like this, you don't actually have to do all this matrix algebra that we're going to show next. We can just use the function LM. I'm just going to show you how that's done so you can see that right away. We're going to talk about LM quite a bit throughout the course. But here I would define the second variable, and I have TT as one of the variables, and I just use this LM function. Again, we're going to describe it later so you'll understand what this tilde means and what this expression here means. But that is really all we have to do to obtain the coefficients, which you can see with the summary function. Here are the estimates. Oops, I'm missing the that's what I did wrong. Okay, so there they are. We can see that the 1/2 times g is here. That's pretty good estimate. The height of the Tower of Pisa is here. That's also pretty good. And then this is practically 0. You can see that there's a it's not significantly different from 0. Okay, so that's how you do this. But what we're going to do in the next video is show you how we can use matrix algebra to obtain the results. The reason for doing that is because there will be situations where LM won't cut it. You'll have to program it yourself, and therefore it's very useful to know how to write matrix algebra operations in R.